Our planet faces a challenge. We need energy to power our lives. But traditional sources like fossil fuels harm the environment. Renewable energy offers a solution. It comes from sources that naturally replenish, like the sun and wind. This transition to renewables is more than just a technological shift. It's a revolution in how we power our world. For decades, renewable energy was seen as a niche technology. It was expensive and inefficient. But times have changed. Innovation has driven down costs and increased efficiency. Renewable energy is now a mainstream power source, and its growth is accelerating. This revolution is driven by necessity. Climate change is a real and present danger. We must reduce our reliance on fossil fuels. Renewable energy is key to this transition. It offers a clean and sustainable alternative. But the shift to renewables is not just about saving the planet, it's also about economic opportunity. The renewable energy sector is booming, creating jobs and driving innovation. This revolution is about building a brighter future for all.
The renewable energy sector is experiencing unprecedented growth. Global renewable energy capacity is soaring. More solar and wind power is being installed than ever before. This growth is driven by several factors. Falling costs have made renewables more competitive with fossil fuels. Government policies are incentivizing renewable energy development, and public awareness of climate change is growing. Solar power, in particular, has seen remarkable progress. The cost of solar panels has plummeted in recent years. This has made solar energy accessible to homes, businesses, and utilities alike. Large-scale solar farms are being built around the world. These farms are generating clean electricity for millions of people. Wind power is also on the rise. Advances in wind turbine technology have made them more efficient and cost-effective. Offshore wind farms are becoming increasingly common. These farms harness the power of strong ocean winds. Wind energy is playing a crucial role in decarbonizing electricity grids worldwide. The growth of renewables is a testament to human ingenuity. We are finding innovative ways to harness the power of nature. This revolution is transforming the energy landscape, creating a cleaner and more sustainable future.
One of the key challenges of renewable energy is intermittency. The sun doesn't always shine and the wind doesn't always blow. This means we need ways to store renewable energy for when it's not available. Fortunately, significant progress is being made in energy storage technologies. Batteries are becoming increasingly important for storing renewable energy. Lithium-ion batteries in particular have become more affordable and efficient. They are being used to store energy generated by rooftop solar panels. They are also being deployed in grid-scale energy storage systems. These systems can store large amounts of energy from solar and wind farms, releasing it when needed. Pumped hydro storage is another proven energy storage technology. This method uses excess electricity to pump water uphill to a reservoir. When energy is needed, the water is released downhill, turning turbines to generate electricity. While geographically limited, pumped hydro offers a large-scale energy storage solution. Other energy storage technologies are also being developed. These include compressed air energy storage, thermal energy storage, and hydrogen storage. As these technologies mature, they will play an increasingly important role in enabling a reliable and resilient renewable energy grid.
The future of renewable energy is bright, with innovations poised to revolutionize how we generate and consume power. Floating solar farms, for instance, offer a promising solution for land-scarce regions. These farms are built on bodies of water, minimizing land use and reducing water evaporation. Bladeless wind turbines represent another exciting development. These turbines utilize vortex-induced vibrations to generate electricity, offering quieter and potentially more bird-friendly energy generation. Advancements in materials science and aerodynamics are driving the development of these innovative turbines. Furthermore, smart grid technologies are crucial for integrating renewable energy sources into the existing grid infrastructure. Smart grids use sensors, software, and communication networks to optimize energy distribution and consumption. This helps balance supply and demand, ensuring grid stability even with intermittent renewable sources. The convergence of these innovations paints a picture of a future where clean energy is abundant and accessible to all. By embracing these advancements, we can accelerate the transition to a sustainable energy future.
Section 5. The intermittency challenge. Intermittency remains a significant challenge for renewable energy. The sun doesn't always shine and the wind doesn't always blow. This variability can pose challenges for grid stability as supply and demand must be carefully balanced. When renewable energy generation is low, other sources must compensate to meet demand. This often means relying on fossil fuel power plants, which undermines the environmental benefits of renewables. Addressing intermittency is crucial for maximizing the potential of solar and wind power. Several strategies can mitigate the intermittency challenge. Energy storage, as discussed earlier, plays a vital role in smoothing out fluctuations in renewable energy generation. By storing excess energy when it's available and releasing it when needed, we can bridge the gap between supply and demand. Another approach is to diversify renewable energy sources geographically. By connecting different regions with transmission lines, we can tap into areas with complementary weather patterns. When the sun isn't shining in one area, it might be windy in another, ensuring a more consistent energy supply.
Section 6. Building a sustainable grid. Transitioning to a renewable energy future requires more than just installing solar panels and wind turbines. It demands a fundamental transformation of our electricity grid. The existing grid, designed for centralized fossil fuel power plants, is ill-equipped to handle the distributed and intermittent nature of renewable sources. We need to build a smarter, more flexible grid that can accommodate the unique characteristics of renewable energy. This involves investing in advanced grid technologies such as smart meters, grid-scale energy storage, and advanced power electronics. Smart meters provide real-time data on energy consumption, enabling utilities to optimize grid operations and consumers to manage their energy use more effectively. Grid-scale energy storage, as discussed earlier, is crucial for smoothing out fluctuations in renewable energy generation. Advanced power electronics, such as inverters and converters, are essential for integrating renewable energy sources into the grid. These devices convert direct current electricity generated by solar panels and some wind turbines into alternating current electricity used by the grid.
Section 7. The economic impact of renewable energy. The transition to a renewable energy future is not just an environmental imperative, it's also an economic opportunity. The renewable energy sector is creating jobs, driving innovation, and boosting economic growth. As the cost of renewable energy technologies continues to fall, the sector is becoming increasingly competitive with fossil fuels. This is driving investment and job creation in renewable energy manufacturing, installation, maintenance, and research and development. Moreover, renewable energy can reduce dependence on volatile fossil fuel markets, enhancing energy security and price stability. This is particularly important for countries that rely heavily on energy imports. Furthermore, the transition to a clean energy economy is spurring innovation across a wide range of sectors. From electric vehicles to smart grids to energy storage technologies, the pursuit of a sustainable future is driving technological advancements and creating new economic opportunities.
Section 8. A cleaner, greener future. The shift to renewable energy is essential for addressing climate change and creating a cleaner, greener future. Fossil fuels release harmful greenhouse gases into the atmosphere, contributing to global warming and its devastating consequences. Renewable energy sources, on the other hand, produce little to no greenhouse gas emissions. By transitioning to a renewable energy future, we can significantly reduce our carbon footprint and mitigate the impacts of climate change. Furthermore, renewable energy can help improve air and water quality. Fossil fuel combustion releases pollutants that contribute to smog, acid rain, and respiratory problems. Renewable energy sources, in contrast, produce minimal air and water pollution, leading to a healthier environment for all. The transition to a clean energy future is not just about reducing our environmental impact. It's also about creating a more sustainable and equitable world for future generations.
Section 9. Our shared responsibility. The transition to a renewable energy future requires a collective effort. Governments, businesses, and individuals all have a role to play in accelerating this transition and creating a more sustainable world. Governments must implement policies that incentivize renewable energy development, such as carbon pricing, renewable portfolio standards, and tax credits. They also need to invest in grid modernization and energy storage infrastructure. Businesses must embrace sustainability as a core value, investing in renewable energy, reducing their carbon footprint, and developing innovative clean technologies. Individuals can make a difference by choosing renewable energy for their homes, adopting energy-efficient practices, and supporting policies that promote a clean energy future. The transition to a renewable energy future is a journey we must undertake together. By embracing innovation, investing in a sustainable future, and working collaboratively, we can create a world powered by clean, abundant energy for generations to come.